Thank you so much, Jay. I'd like to invite the panelists to come on up, join me. While they're doing that, how about a round of applause for the Sagamore Institute for these couple days? Just been incredible. For those of you who were at the afternoon session, Dave Tamelis led an awesome group then. So if you slept on the pre-session this year, make sure you come back for it next year. It was extremely valuable. But the whole Sagamore team, Jay is a great friend, and just think the world of him personally. And you talk about somebody, the need for innovation, the more things we can get Jay involved in, the better for the whole country. And certainly Dr. Hendricks, thank you for just all the strategy behind this event, all your work to get it off the ground. And Rob Panos has been incredible helping all of us get organized. So thank you to Rob and the whole team. We can just jump right into questions here. I would love for the panelists to do a brief introduction of themselves, if you don't mind, with this first question that I'll ask. But just to kind of frame this, as Jay mentioned, we're gathered here in the home of the Wright brothers. You can walk through these 4 buildings and see the entire really history of aviation. So the question for these experts and leaders in this field is, what is going to define this next era of air power? And maybe John, we can start with you.
Can you hear me? Oh, great. Well, yeah, good evening, everyone. I'm John Kusnierek. I lead Rolls-Royce LibertyWorks, which is an advanced propulsion technology group, which is obviously associated with Rolls-Royce, the big Rolls-Royce North America. We're based out of Indianapolis. Had a variety of involvement in propulsion topics, propulsion technologies. Many of the aircraft in the museum actually have propulsion that originated from LibertyWorks and its predecessors. I think to answer the question, I would reflect that this is probably the period of the most intense, rapid, and at-scale technological change that I've seen in my career. Arguably, actually going back quite a while. You want to try to think of it as a situation where if there was the computer age, the cell phone age, the jet age, and we'll throw AI in there as well, all happened at once. It's almost that level of startling change. So what you may see today in terms of the things that are being worked on, those will change rapidly in the future. I think the answer to my question, or to your question, Andrew, would be that I would expect that all aviation systems will ultimately become smaller. Now, that doesn't mean everything turns into a quadcopter, but a larger aircraft would be half that size, and so on down the chain of aviation systems. I believe that also the quantity of those systems would be dramatically larger in terms of the number of systems. I believe that the adaptability of those systems and complexity will basically be much greater than today. And you want to think about definitely think about self-thinking machines and how they assist with the accomplishment of various missions. So that is where I think we're headed.
Thank you, John. AJ.
Yeah, thanks everybody. AJ Piplica, I'm the co-founder and chairman of a company called Hermeus, where our goal is to build the world's fastest aircraft. Been at it for not quite 8 years, but I think I've made some pretty good progress there. Just flew our first supersonic unmanned aircraft a few weeks ago, about the size of an F-16. Goal is to bring this capability into the warfighter's hands here this decade and continue to scale from there. to answer the question around like kind of what's coming, I think the future is defined. It's actually pretty similar, I think, to what you spoke to first, Andrew. A rapidly evolving threat environment. We look back at the Cold War. We kind of knew what the threat environment looked like. We could project forward, I don't know, 5, 10, maybe even 20 years with a little bit of uncertainty and give ourselves a reasonable understanding of what capability we would need in that time. And it was a good thing we could do that because it took us that long, decades, to create new capabilities. Well, unless you've been living under a rock, you know that the threat environment that everybody deals with in the world now from a military perspective does not evolve on the order of decades. It evolves in the order of hours. I mean, talk to anybody who's been to Ukraine. You see that. But even at the great power level with China and the Pacific, our adversaries are pushing to advance technologies, create new capabilities, and scale the production of them much faster than our system is designed to react. And that requires, I think, a very different approach. I wouldn't even say a novel approach. I would say a return to our roots. All the aircraft that we see around us here, so many of them were built or conceived of at least in between 1945 and 1975. That was the heyday of military aviation. We built so many aircraft in that time, and it took us a handful of years to get them out into the field. The average time between 1945 and 1975 was about 4 to 5 years to field, not just a prototype, but field something into production, put it in the field and in the hands of the warfighter. Today, the F-22, F-35, V-22, those were all 20 to 25 years just to get to an initial capability. When your threat environment is evolving even on an annual basis, the requirements you come up with today for your fight 20 years from now, you have no idea what they are. So I think what that really requires of us in our seats up here and across the defense industrial base is really to think about what it takes to win in an environment like that. And I think there's kind of 2 core components. Number one, you have to be able to create new asymmetric capabilities quickly. What I mean by asymmetric is they impose more cost on your adversary than it costs you to employ them. And number 2, you need to be able to do that at scale. Because we do have asymmetric capabilities today. There's no question about that. We don't have a lot of them. And when push comes to shove, don't expect that they're all going to be available for all the missions that we want to conduct with them, let alone how survivable they are. So the production piece is critical. Now, we've invested a ton in production. You see much of defense technology focused on scaling the production rate of a lot of military systems, but most of those systems are small. Most of them you can hold in your hand. To the size of a quadcopter or a small, collaborative combat aircraft. Putting those 2 things together is really where we need to be focused. And I think there's a reason that nothing exists in that box today. It's because it's incredibly challenging. But I think that is a challenge that's ahead of us, is how we fill that box.
Thanks, AJ. Tom.
Thanks, and good evening, everybody. I'm Tom Deale. I'm on the government relations staff at Northrup Grumman Corporate. Retired Air Force, 32 years. Served most of my time flying A-10s for you, so appreciate your proud comments back there. Really rang true. Haven't jumped out any of these airplanes here that we have in the hangar, but I've flown quite a few of them, to include the A-10 that they have on display over there, if that makes you feel old or not. But appreciate the comment, Andrew. I'm going to piggyback a little bit on what AJ said. I think really we're looking at an inflection point. You look at where the Air Force is going with the advanced air superiority, air dominance constructs that they're working on, and we're seeing a shift away from a platform-specific capabilities more towards a system or a system of systems capability that's really going to diffuse and spread across where that capability is going to come from and where the mission effects are going to get generated from. And I'll add some details to that. I think we're going to see 6th generation platforms acting as kind of like command nodes forward in the battle space. But they're going to require several contributing factors. First off, and as AJ mentioned, as well as John, the human to machine teaming that's going to happen in that environment. When we're talking about a crewed capability that's in the highly contested environment, it's not going to be cheap. It's going to have to be survivable, and we're not going to have that many of them. And so, how are you going to get your mass there? And that's where you start talking about some of the attritable, some of the man-on-man teaming. The Air Force has several projects ongoing with that. When you look at the Collaborative Combat Aircraft program and others across that portion of the industry. I think you're also going to see integration like we haven't seen before. We've had radio communications, we've started fighting on networks, but you're going to see an integration to a level unforeseen in sensing, both from a sensing perspective, from an effecting perspective, or what's shooting the weapons, to a battle management perspective. Not just integration across the air domain, but also including space and space-based capabilities and where that's going to tie in to it as well. It's also going to be at range, either standoff in weapons or having to affect operations from a great distance. And if we're talking the Indo-PACOM AOR, we're talking greater than 1,000 miles that you're going to have to deploy into in order to have significant effects for that. And then, as AJ mentioned, the threat and where the threat is going and where the threat's evolving, and nobody is going to guess what the threat picture looks like accurately enough. The trick is to be close enough where you're least wrong, so that as you have to iterate, and everybody's going to have to iterate, you're closer to the right solution and the right capabilities than you need to, because tomorrow's threats evolving into a all spectrum, all domain threat. Talk ground, talk air, talk space threats, talk IR, EO, electrical, optical, even acoustic threats that we're seeing across the battle space these days. And so when you look at that from an access perspective, it really raises the table stakes for what survivability properties you're going to need for a lot of your capabilities just to get to the position in the battle space in order to have the effects that you need to. So it's not going to be easy. The Air Force, given that we're here in the museum, is working on they're working on fielding the capabilities that they see they're going to need to fight that future fight. And I know all of us are working towards helping them do that. So thank you, Andrew.
Thank you, Tom. Thank you all. So I think each of you hit on, to steal the line from Top Gun, the need for speed, not just with aircraft, obviously, but in innovation, testing, acquisition, production, deployment, the whole development pipeline. So could you talk about what the U.S. is doing well from that perspective as far as speeding up, adapting to the speed that's required across that spectrum, and maybe where the biggest challenges are?
Yeah, I'll lead off. I think the place that is the actual frontier of rapid prototyping and rapid development isn't quite here yet. And it relates back to the engineering cycle, which relates back to how quickly we can rapidly field new designs, not just the aircraft physical shells you see, but all the software required to make it run. And where this kind of threads back to then is artificial intelligence augmenting engineering activities, augmenting software coding capabilities. That's where you're moving from an era of a 12-month engineering task taking minutes. And I think that's really where the action will be in a few years. I mention that in part because, in the Midwest here, this relates substantially to the academic footprint in the area. And I think that it's recognized that AI and the use of AI will be very important. Probably one of the principal differentiators between an adversary that can adapt very quickly and an adversary that's using processes from the Cold War. The part that concerns me the most in terms of lagging is actually risk taking. AJ's team, congratulations, definitely able to take risks and successfully take risks. In the Cold War, we did not have to take that many engineering risks, so we took a lot of time. That's simply not going to be something that's acceptable in the future. Risk and risk taking go hand in hand with failure. And that's when you need to be able to rapidly iterate to the next version. And I think that's one of the things Tom was referring to as well, is basically this succession, this very rapid succession of fielding of new systems.
Yeah, I think there's a lot that we're doing well. If I look at what this specific administration has done over the past roughly 2 years, to really, I think the clearest way to put it is get serious about the fight that we have to prepare for. Move out of the way all the stuff that doesn't actually matter and focus on the things that do. One area where they've leaned forward quite a bit is in reforming the acquisition system for all sorts of military systems. The the fact that how quickly we can buy something is the driver of how quickly we can have something ready is kind of insane. If we're ready, we should buy it right now. Why not? So it's such a very simple and trivial thing to say, and yet we spend years and years trying to perfectly plan our budgets, and yet as I think it was Eisenhower who said, plans are useless. Planning is indispensable, he did say, but plans themselves are useless. So yeah, I think that is a key component that enables a lot of this innovation that's happening out there to be adopted. And the administration, I think, has been able to do this without really changing policy or laws or anything like that. They have done it by driving changes in behavior and culture. And that is the only way to actually change the outcomes is to change the behavior and the culture. And that is something that this administration, certainly within the Department of War and Congress for that matter, are absolutely willing to go affect the change on. I think in terms of bottlenecks, things like that. I mean, I'll speak to one pretty close to home when I look at aviation innovation and what are some of the things that slow the pace of that. The bottleneck that I see out there is our test ranges. They have been neglected for so long. We have so many new systems. It takes us way too long to test them to the level that we're happy with them and get them out into the field. And we have multiple national asset test capabilities for flight test, and yet our throughput through those facilities, because of the aging of all their equipment and the lack of modernization, just as little as we've modernized our military, we haven't modernized our test infrastructure for it either. And for a company whose approach relies on real world testing to get real world data, iterate based on that, not based on analysis, the throughput, the operational cadence that we can go test is critical. So to piggyback on the risk stuff, to let you guys in on a little bit of the sausage making. So we flew this first supersonic jet on May 20th. That was our third flight of that aircraft. I think that aircraft had a solid 35 minutes of flight test under its wings by the time it went supersonic. That's kind of dumb, and in a lot of cases, I think people would look at that and say, wow, you guys took a lot of risk. And to some extent, the answer is yes, absolutely. Not only did we design our aircraft to take that type of risk and be successful, not only did we design our team to do that, but we also designed our organization, our company, and our program to do it. And the only way we could do that is by building lots of airplanes. So the way that I, as a leader of the company at the time, was willing to say, yes, let's go take this risk, was because, number one, I knew the way we were flying this aircraft, there was no chance of any harm to a human being. That takes risk to a completely different level. Person on the aircraft, people on the ground, or otherwise. Second, I knew that we have another aircraft in our factory. It's going to be ready to go in a few months. So if we happen to lose this one, pushing the boundaries, we're not going to lose years on this program. We're bounded. The next airplane will be ready by the time the investigation is done. So that really bounds how quickly we can get back into flight. But like without that preparedness, like you can talk about taking risks, but you really do have to plan these things programmatically, organizationally, and technically in order to be able to take them in an intelligent way where, taking risks, the consequences aren't years and years of slippage. To speak to some of the AI stuff, the first 2 flights that we did with this aircraft were, I think the max altitude we hit was less than 10,000 feet and maybe Mach 0.4. So we went and flew a supersonic sortie, basically having never expanded the envelope beyond those conditions. So our ask of the technical team was in situ, while that airplane is in the air with no person on it, you were sitting in the flight deck. The first time we turned all the controllers on for the first time, where it's not just like straight, stick and rudder to control surface movement, but all the advanced flight software is flying on the aircraft for the first time. We need you to process that data and make a call as to whether or not we're good to expand the envelope, hit the afterburner, and go supersonic or not. And no big deal. It's just, tens of millions of dollars sitting out there that could very easily end up as a pile of, flaming rubble in the desert. 10 seconds, no pressure, go. That doesn't work without the tooling to do it. And that's a place where we've implemented AI in our business, not from a design perspective. Like people talk about how the SR-71 was designed with slide rules. Well, we designed this airplane in Microsoft Excel. Yes, we use plenty of other advanced tools to validate everything that we design, but like design is not the hard part. The hard part is actually building it, making it work, and then testing it in a way that is actually going to push the envelope, intelligently. So, our engineers were able to boil down that incredibly challenging and business, impactful decision to, I need to look at this number, I compare it to this number. All the processing's ready to go. Yes, we're good. Yes, we're good. Balls to the wall. We're supersonic. So yeah, I can't underscore enough how critical not only the ability and the willingness to take risk, but the capability of doing it intelligently is to advancing some of these things on the timelines that we're asked to do it.
Yeah, I'll piggyback on that too. I congratulate Hermeus on the culture that they have in order to drive that decision making for it. I mean, that is, I wouldn't say that is standard across the industry.
Yeah, they tell us that when we're at White Sands, they're like, "What are you cowboys doing?" We're like, "We're doing what we think is right. This is why. Like, please tell us we're wrong. We'd love to hear it."
No doubt.
But I mean, they approved it, so we did it.
Yeah. But to expound on what AJ did talk about as far as some of the Department of War's recent changes and the warfighter acquisition system and then changes that they've made really have been significant. When you look at some of the investments the department has made directly into certain critical capabilities or critical materials and elements needed for national security reasons, I've never seen the department become part owner of a company before that's doing that, before this administration did that, and breaking through and changing some of those changes that were commented on earlier. That's just one example of it. They're also working with industry, looking at how do we increase that capacity, or how do we have that capacity on call, or what do we need to do to ramp up and get you capacity. And from an industry perspective, it's what's the business case that supports that, and how do we make that, how do we get that happy medium for that. Another thing that they've done to help accelerate is the stand up of the direct report program manager offices for some of these key capabilities that they view as critical to the future warfighter. You can look at one for Global Dome for America. There's another one, General White, with several of the Air Force programs that are out there. But they've really centralized the acquisition right under the primary resourcer for the department in order to drive and accelerate fielding of these capabilities that they deem critical for national security needs for it. And that is a whole new construct that is really outside the box thinking for how they want to structure that. I won't say that we've got it licked. There are still bureaucracy delays to procurement that we are still facing that are holdovers from an industrial age. The best we can do is identify where those are and work them and identify them. And I would say that this administration and the department is very receptive to those inputs and driving change in order to affect those. AJ mentioned the test range infrastructure. That's dated. It's not to the capacity that anybody needs if you're going to accelerate fielding of capabilities for that. Global supply chains are also another limfac that we're all working against and working for, and they're very fragile. And then finally, as I touched upon earlier, manufacturing capacity. You know, for 20 years, the defense industry has been driven towards efficiencies, which gets you very lean supply chains. It gets you production capacity just to meet what the requirement is to produce. And especially if you're a publicly traded company, as I commented earlier in some other sidebar conversations, you know, if you're a publicly traded company, you're not doing your shareholders justice if you've got production capacity just sitting idle for it. So you've got to find some creative ways in order to address that. The department's very interested in making sure industry can surge production when and where needed for it. And you look at the munitions and what they're doing with that currently is certainly one of the key examples and a very near-term challenge that the department and the U.S. defense industry is going to have going forward here in the very near future. So thank you.
Thanks, Tom. So maybe we do a little bit of sort of rapid fire one-on-one questions. I have one question for each of you, and then we'll have at least one for the rest of the group here, depending on time. But maybe Tom, we'll start with you. Northrop Grumman obviously operates across some of the most advanced air defense systems in the world. You have these trends with autonomy, attritable systems, and just the general changing nature of warfare. So how are those reshaping just this era of air dominance, this next era?
You bet. So we talked about manned-unmanned teaming, crewed, uncrewed, where that's going. What that provides you is mass at an affordable price. To the extreme, it would be an attritable price for it. But how are you going to get massive capabilities in order to affect operations? That's really where the shift is. So when you look at Northrop Grumman and autonomy and autonomous systems, we've got 20 plus years of experience doing that. But I would say we're at the high end of the capability, and we're not exactly what you would call it an attritable price point. We're not selling Global Hawks just to get shot down left and right for it. The country can't afford that, and that's not what the needs of the department are right now. So internal to the company, as a large defense prime, we had some experience in the attritable class, but most of that had been in our munitions area for that. But how do we migrate that up for it? And we had a good hard look at ourselves. If you're familiar with the Air Force's CCA program, Inc. 1, there were several vendors competing for that. They down selected to 2. Northrop was not one of them. Took a good hard look at ourselves in our business from both manufacturing, from design, from capabilities. You know, nobody has ever asked us, make us something that's just good enough and cheap enough where we can buy a whole lot of them. That's not exactly our niche. But the company recognized where the future is going and the future need for that class of a capability, and really did a hard internal look to come up with benefiting from some of our subsidiaries' work in prototyping in order to field what the Air Force designated as the YFQ-48. That's a Talon program, which is designed from the start differently than anything else Northrop Grumman had done, because it's designed to manufacture cheaply, but also to manufacture at scale. And then it's got enough modularity in order for it to adapt as the needs evolve for whatever this class of, I'll say it's attritable, but it's more like the reusable. But if you lose it, it's not unaffordable to lose, and that's where we're going to. But there's a lot across the industry is doing the same. There's a lot of startups that are entering in and doing the same for that. And so the future is in adaptability, in open mission systems with government referenced architectures, because the government's very interested in making sure that they can swap out mission systems as needed without a lot of integration costs. Built two standards in order to adopt that, as well as coming in at a price point that allows them to buy them in mass. If they can't buy it in mass, it's not going to be as attractive to them, and they're going to need to do that. And I think that's where the future is, and that's where we're working towards for that. Thank you.
Thanks, Tom. Back to you, AJ. So Hermeus has become known for rapid iteration and pushing timelines that many in aerospace at least once thought impossible. You've kind of alluded to this, but maybe without revealing your secret sauce totally, what lessons can the broader defense ecosystem learn from your approach?
Yeah, so to put some things in perspective, I didn't realize there were going to be so many historians in the audience tonight. So please, don't fact check me, or do. Hopefully, I'm correct. Going back to one of my original points here around being able to create new asymmetric capabilities quickly. There have been hundreds of supersonic aircraft that have been developed over history, developed by dozens of different companies. Very few of them have done them quickly. So this guy above us, from contract signature to first supersonic flight, the XB-70, 6 years, 9 months. The X-10 that's sitting over there, that's kind of our rival, because the only reason I can't say we have the fastest supersonic unmanned aircraft, because that's it. That guy was North American Aviation, I think, 4 years, 1 month from contract signature to supersonic flight. YF-23, arguably the coolest airplane. Maybe not, but some do. I think it was cooler than the one that won, but we'll leave that for the history books. 3 years, 11 months from contract signature to first supersonic flight. And then this guy here, or at least its predecessor, is a YF-12, so the A-12, which was the predecessor to the SR-71. 2 years, 3 months from contract signature to first supersonic flight. Now, all of these aircraft were not the first aircraft that any of these companies built. It wasn't the second aircraft either. But you can kind of see a trend. The further back in time I go, the shorter the amount of time it takes. And with Quarter Horse, the Mark 2.1, the one that we just built, flew supersonic, wasn't the first aircraft that we built. It was the second. The first aircraft was about a 10,000 pounds uncrewed aircraft, Quarter Horse Mark 1, flew last year in May. But the Mark 2.1, that one from what you would call equivalent of contract signature, so like conceptual design is done, you're off. 1 year, 11 months. So like that is the pace that's required over and over and over again. So many times, and like organizationally, you kind of have to resist the temptation to say, well, why didn't you go build the actual thing? Why don't you go build the product? Go build the Mach 5 airplane. Go build the Mach 3 airplane. The only way you realize that it's actually faster to build multiple airplanes in series, each one taking on the next risk, than trying to go build the one perfect thing right off the bat. The only way you learn that is by trying the first time. And like we tried that too, and we found out, oh, well, this is the wrong path. And when we completely changed our aircraft program about 3 years, a little over 3 years ago, to fix that. And now we've got a design team that can turn out a new aircraft, roughly every year. You look back at the guy who designed, chief designer of this guy here, Kelly Johnson. 40-year career, 41 new aircraft into production. The ability to do this quickly doesn't come from studying. It doesn't come from analysis. And, you're not also born into it. Like Kelly Johnson wasn't born some aircraft design savant. He cut his teeth in the University of Michigan wind tunnel right here in the Midwest, working plane after plane after plane, trying to learn enough so that he was good enough to earn a job at Lockheed Martin, or Lockheed back then. And through that iteration, I mean, he'd probably seen more airplanes in the tunnel than 3/4 of the designers at Lockheed. And that showed when he showed up his first week. He shows up and he meets with like the VP. He's like, hey, so this airplane that you guys just designed, that's supposed to be the crown jewel and save the company, yeah, it's unstable. If you put it into production, it's going to kill the company. And lucky enough, they said, okay, kid, you got 2 weeks, go prove it. And he went back to the wind tunnel, and sure enough, he proved it, and then he got to do whatever job he wanted from there on. But my point is, you can't create a team that can do this kind of thing from scratch. Like when we started the company, there was nowhere we could hire from. where could you hire today where people had put out new airplanes on an annual basis? Nowhere. They're all dead. The only place that pace of iteration existed was in the commercial space world. So that's the choice that we made. We hired a bunch of rocket people to build airplanes, which a lot of people looked at us and said, like, hey, where are your airplane people? Where are the people who know like landing gear and aerodynamics and air breathing propulsion? And we're like, yeah, you see them, they're right here. They're going to learn it. And they're going to be back in a few years. You just wait. And they said, okay, fine, come back and show us. And here we are, and we're making our way. We have a long way to go, but like that pace of iteration is not just for new capabilities. It is for training the next generation of aircraft developers and aviation developers that give us the capability to do this not just once. Like you do it once, it's a fluke. You do it over and over again, it's a streak. And that's really what's required to meet, I think, the challenge that I spoke about at the beginning, this rapidly evolving threat environment. You can't just create one wonder product. That's not going to work. That'll be obsolete in 5 years. So the trick is when that 5 years comes along, you're 5 iterations down the road and your adversary is still trying to pick up their homework. But that only comes from building a workforce that's not just theoretically capable of doing this, but that has done it day in, day out. And I hope that people leave our company and start their own companies and break some of the records that we hope to break one day. I think that's the only way that our country is in a position where not only can we win a fight that we might find ourselves in, but that we can actually achieve the number one goal of our the entire reason the Department of War exists, which deter conflict from happening in the first place. And I think again, the only way we can do that is through creating these new capabilities, especially in the air domain, and then scaling the production of them. So yeah.
Thank you, AJ. Well said. So John, Rolls-Royce, obviously propulsion is foundational to every leap in aerospace capability. So what developments in engines and power systems do you think will have the biggest impact on this next generation of aviation?
Yeah, definitely in a kind of on the precipice of a kind of a revolution in jet engine production. One of the topics related to that is additive layer manufacture. That may be somewhat less familiar to the audience, but this is fundamentally different than machining metal. It's actually welding metal in layers and building up a part. The interesting thing is that it fundamentally changes the supply chain. So one of the largest issues in the propulsion industry is the supply chain, and a lot of that runs through metals and casting houses, machine shops, and so forth. And so if you can have a broad technology that is widely applicable to the kinds of things we need, that's really quite revolutionary. The other thing is composites. That's again perhaps somewhat less familiar to the audience. Composites have been around for a long time. There are ever better, ever newer composites with ever higher temperature capability, and so that's another of those technologies. I would again say from a Midwest defense standpoint, both of those are fertile ground for investment for academia and for standing up companies. I am struck, here in the museum, you can go find the Wright brothers little 12 horsepower engine about the size of a bread box, and that engine was just good enough to get the airplane off the ground and fly for a short distance. Very rudimentary. Actually had almost, in terms of controls, almost none. Very hard to start. Very narrow range of operation. But that was the start of aerospace propulsion. And then if you walk through, as many of you have now, walked through the progression of the propulsion technologies, underlying all of that certainly is innovation, but really foundationally it is materials and fundamentally, honestly, the supply chain. So we really look forward to building new engines for new airplanes once a year. I think that'd be a grand challenge for us. Lots of things happening across the industry, and it all relates back to the technological opportunity that I think we're seeing broadly. as described here by the panel members.
Thank you, John. So maybe the last question for the group here. So I took note of AJ's comment, sort of lamenting the state of some of the test ranges. So just this year, ARI worked with our partners in Indiana state government. I don't know if Jan Schuler-Hicks is here at the IEDC to secure an FAA test bed for UAS testing, which is part of a broader Midwest strategy to really coordinate testing, iteration, and production of autonomous systems. So the question for you all is, how can the Midwest utilize that asset and our other assets to become really the epicenter of this next generation of autonomous aviation?
Yeah, certainly opening up the skies in a way that is safe for obviously the uninvolved public and everybody, which is not just an airspace problem. It's a ground challenge as well. The smaller your systems get, the more flexibility you get there for sure, and the higher the iteration rates can be. So, but there's lots of places in the Midwest where population densities are extremely low, and there are some like interesting airfields in the area. So, one of the things that, like, the reason that we go to a federal test range that has all these constraints and bottlenecks is because we have the particular one that we fly at in New Mexico has a commercial airfield in Spaceport America inside restricted airspace. So the safety case is extremely simple. Like, there are no other airplanes flying. There are no people on the ground. Anything can happen with the airplane so long as it stays within these bounds. So you don't care whether the airplane crashes or not because it can crash safely. Like, that is the ultimate pace. That's the ultimate pace enabler. But I mean, even that makes our test ranges uncomfortable. So, yeah, the more ways that they were able to do that, I think is great. I don't want to just like only think about test capabilities in the air. On the ground is hugely important, especially for propulsion. When you think about not like there's plenty of things that are hard about testing high-speed air-breathing propulsion on the ground. There's only a handful of facilities in the country that can do that. But everything across the propulsion spectrum, I think the more you can test on the ground, the more, honestly, noise you can make, the faster you're going to be able to iterate there. So, yeah, I don't want to forget about the ground-based test capabilities, not just for hypersonics and fast things, but things that fly slow too. I think that's super critical. And there's tons of obviously great universities here in the Midwest that not only support the workforce but support some of the test facilities. The first engine test that we did as Hermeus, we came to the Midwest. We came to Purdue. We tested at Zucro's hot gas facility to test our pre-cooler for our turbine engine and our ramjet for the first time. And the reason we came is because it was inexpensive. Also, they staffed it with grad students, which was a great way for us to like hire people. And they kind of allowed us to take risks, and that was critical. So I think that the more facilities like that at various scales that are available, I think it really helps all around.
Yeah, I would just add, I think also the Midwest has a lot of the organizations that are designed to help fertile public-private partnerships really mature into actual manufacturing centers and results. You look here locally, Jobs Ohio, Dayton Defense. There's a couple. Your company and what you did up in Indiana as well, looking for those advantageous synergies between where there's a need and in our business, it's what's the government's need for it, and then looking for the right manufacturing center in order to help support that. You can look at the headlines and see some of the tax incentive and tax liability states out there and where manufacturing is either going to or going away from. And you see a lot of advantages in the Midwest for that. And then to piggyback on what AJ said, the talent pool's there as well. And there's a lot of unique opportunities to generate that synergies where you've got technical expertise combined with a public-private partnership opportunity that really gives you some fertile ground here in the Midwest in order to develop some of what we're looking for, which are, business outcomes, manufacturing outcomes, and continuing to contribute along those ends.
John, any thoughts on that?
No, it's just I was reflecting in the early days of aviation with rapid iteration. There actually was a very close collaboration between the automotive industry and the aviation industry, and the Midwest is full of automotive. So that could be a avenue for some fertile exploration.
Thank you all. So I understand there's some demands for some encore time for you all. So we're going to extend the time a little bit and see if there are any questions from the audience, since we have quite a few distinguished guests with us for this panel. So we take a minute and see if there are any questions from the audience. Yes, sir.
Commercial innovation that's outside of aviation contribute to what and how does that look? What do you want to see from the private sector to help you iterate?
Yeah, so question basically what can the private sector do to support more rapid innovation and iteration in this space? Great question.
I'd say like look at some of the bottlenecks that we've talked about up here on stage and go attack those. I mean, I would love to pay oodles of money to somebody for range time. Like, yeah, that'd be fantastic. I mean, I don't know if I would like point to specific problems and say, hey, we in the defense industrial base have these problems, commercial companies, can you like come solve them? I think it's really the other way around. You know, we in the defense industrial base, it's incumbent on us to understand what capabilities are out there that we can apply to the problems that we have to solve in a way that maybe we haven't been good at in the past or haven't been willing to try or risk or whatever in the past. I know it can be very challenging for companies to bring in, or organizations doing high stakes things, whatever they may be, to bring in new organizations, new startups, bringing hardware, software, whatever the solutions is, and putting them in your critical path. The story I told you all earlier about like making this incredibly high stakes decision in 10 seconds, that wasn't a Hermeus tool that was built. That was a tool that we bought from a startup called Nominal. That the reason that they exist is to accelerate like test data and rebuild test data infrastructure, layer AI on top of that, and make it modern. And we've been working with them for a number of years now. This wasn't our first rodeo with them, but that was a crucial piece of us being able to achieve the things that we were able to achieve in the timelines we were. So yeah, I think the question is really on us is what can we do to find the problems that we have, that capabilities out there that exist. We don't have to go reinvent the wheel on. We can bring in, integrate, and solve.
So I am constantly on search for new startups, new technology avenues, and one of the striking things to me always is we're always surprised. There's an innovative company that has something that we need that has perhaps been in existence for a number of years and fundamentally comes to us accidentally. And always happy to have a good, positive outcome for something like that. But, a kind of a forum or some interaction promulgated by some entity would be probably useful.
Yeah, and I just look at it from two approaches. On the industry side, and this isn't just Northrop Grumman, we're always looking for those differentiating technologies that we can bring on board for it, either through mergers, acquisitions, or just buying the capability from that. And I think across industry, there's history of all of the companies doing that to certain degrees. On the customer side, if we look at the government side, you're seeing a subtle shift as they start adopting more common architectures and common interfaces, where it's not so much the platform itself that defines the capability, but the mission systems. And that's going to change and enhance the role of a lead system integrator as opposed to a prime platform provider. And I think that's an emerging construct that's going to enable both the acceleration, but also the inclusiveness of a more dispersed industrial base that brings some of that innovation, some of those smaller business opportunities for that as that matures. The problem is going to be who pays for the integration. If the government's going to be the integrator, then the aircraft prime's happy to charge the government for that if they're going to make all the source selections for it. So that still has to work through the business model for it.
Thank you all. Other questions from the group? Yes, ma'am. In the back. Maybe I'll give you the mic for a minute.
Thank you. Practical works.
Practical. Sorry. I work at a prime and you guys work at primes, right? And I've worked at a small startup company in my career, and it's always hard to get the practical matching up the suppliers. We've got lots of suppliers that are a part of this board or this association that I'm part of, and they would love to be part of our primes, but you can't get through to the people that need them, the programs that need them. How do we get them connected? You know, what's that practical way? Do we do a matchmaking session? You know, can you guys help me figure that out? I would love to do that. And also the test bed.
Yeah, that's a rough one. I'd almost say something like a speed dating session, a Shark Tank environment, something that is somewhat informal would probably help. But I don't have a complete answer for your question.
All right, you may like this, you may not. Go on LinkedIn, find the supply chain leader, and call them or send them a note. They'll probably call you back. I mean, I kind of joke like tongue in cheek, but it is actually true. I mean, like we get pinged all the time from folks all over the place, and our supply chain team is craving multiple solutions for pretty much everything that we go after. So we're willing to have pretty much any conversation at any time. But there's always that door, anytime.
And Jay's going to love this one. It's forums like this. It's making the connections and the networking that you get at these sorts of events that are going to give you a lot of that connectivity. Otherwise, you just have to keep your ear to the ground and look for when either large defense primes or even mid defense primes are holding industry days for certain projects and bringing folks in. I will say, though, the largest challenge from a defense industrial base is when you start talking about some of the more restricted capabilities and restricted work, because that ends up closing ranks very quickly and access very quickly to break through that. And that's where you've got to really work with the government customer in order to affect that.
Thank you all very much. Maybe just one last question for me real quick. I see Jay's coming up, but we heard about Dr. Hendrix's favorite aircraft in this museum. So for people like me, it's the first time. Jay is a first timer. What do we need to see before we leave here tonight? Any tips?
The A-10's over in Hangar 3. Make sure you drop by there and see that. That's one of the best looking aircraft here.
Does this still go Bert?
They call it the Thunderbolt 2, but pilots in the ground crews call it the Hog.
Thanks, Tom. Any other?
Let's see. I'll be a little less cliche. Go see the D-21. So of course everybody loves the S-plane. Everybody has posters up on their wall. D-21 is an amazing piece of technology. Mach 3 drone launched from the back of the SR-71, flew 3,000 miles over China. Yeah, that was a real fun one.
Yeah, two-parter. X-15 right here. Innovative, imaginative, really awesome airplane. And then you have to go to the back of the XB-70 to look at the 6 engines. You can. There's a space back there. If you haven't been back there, you need to go.
Thank you all so much. I want to all of these panelists for joining us. I do want to give Tom a special shout out. Not the first time in his career he's had to adapt and overcome, but I think he had the most difficult logistical trip to get to
rapidly
join us today.
evolving
so really appreciate
environment, huh?
That's right. So thank you all very much. Back to you, Jay.